Greetings everyone, good morning, good night, good evening, depends on the time zone you're at. Now, before I actually kick off this video, I want to announce something that I'm working on. This here are a couple of screenshots where we are going to be building a Discord clone. You can enter it's going to be a chat room. Obviously, it's going to allow you to talk with your friends. So it's going to retransmission voice, it's going to retransmission chat. It's going also to allow you to share your screen between every single participant. This is going to be an amazing project. So if you do not want to miss it, like and subscribe. All right, you can just subscribe, I guess. And if you find this particular video currently that we're doing useful, then you can also like it. So this was about the announcement that I want to do. I'm going to make a couple of other announcements when I develop it further on. But currently we are going to be looking at problem 66 plus 1. This problem was given by Apple in a coding interview, and today we're going to be writing a solution in JavaScript. So let's read the problem. You're given a large integer represented as an integer array digits, where each digit of I is the ith digit of the integer. The digits are ordered from the most significant to least significant in left to right order. The large integer does not contain any leading zeros. All right, so increment the large integer by 1 and return the resulting array. Now this is going to be a bit different in JavaScript, but in reality we're going to have the same idea as I did in the C# video. But I do understand that most of the people do not care about C# and they just want to learn JavaScript. So most of the C# videos are actually missed. So that is why I'm also going to do the explanation in JS. I don't know how I actually start. All right, that's weird. I'm just going to close. So I'm going to Control A, delete here, so I have a bit of writing space. Now, in reality, Control Alt D to write. Nice. In reality, this problem is pretty nice. I really like this one. Let's say that we have this integer 1, 2, 3, and it's going to be an array. So it's going to be represented as this. What you can do is, so this is the first solution that I did, and I actually failed. I'm going to tell you why, but let's see if you can actually handle it. So what I did is I append each and every single digit as a character to a string. So in the end, when I go from left to right of the iteration, I end up with a string being 1, 2, 3. Now this string I cast to an integer. So it's going to be obviously the same integer here, 1, 2, 3. Then I'm going to add 1. This is a very simple operation because, as you know, this now is an int and this now is an int as well. So I'm going to write this, and this is going to be a string. Now, this is great. And after that, each and every character, you can actually put it back as an int to an empty array and just have the following output, which is going to be great. This is actually going to be the right result. Problem, however, is if you have something more, for example, 70 characters, right? You're going to be wanting 70 bits, and that's where the problem is going to come. If you try to cast this string to an int, you're going to hit problems. You're going to be hitting, depends on the language. In C#, this is going to be an overflow, but in other languages, you're just going to miss a couple of bits, because if I represent the number with 32 or even 64 bits, I'm going to have, right? So it's going to be 0 and 1s, but let's just say XY, XY, XY. And if I want to put some more data over here, I'm just going to lose this data in front, and it's going to be an absolutely different number. So that's a problem. Now I'm going to Control Z's all the way. And the second solution, which is the working one, is the following. Let's say that I have 1, 2, 3. And I'm still going to start with the example. I'm going to start with the simple example first, because the all 9s is going to be a bit more complicated. Now, I'm going to start from the end, and I'm going to make myself path to the beginning, right? So I'm just going to start not from 1, I'm going to start from 3. And I'm going to check, is this number less than 9? If that is the case, then it's pretty simple. I'm just going to change this. I'm going to swap this number, right, with 1 up. So I'm going to have 4 here. So I'm going to place 4, and then I'm just going to return the simple array. The simple array is already changed, so it's going to be 1, 2, 4. Very simple, very slick. And the only problem with this solution, however, and why I actually began with the string, is what are you going to do if you have all 9s? So it's actually very simple. Again, you're going to start from the end and make yourself way to the front. And you're going to see, is this less than 9? Well, it's not. So what you can do, because you need to add 1 to this, you're actually going to create, actually not create, but rather change this element to a 0 and go one step ahead to the left. Going on to the left, of course, we're met with another 9. So this time I'm going to do absolutely the same thing. I'm just going to write a 0 and I'm going to go left. Again, the same case, I'm met with a 9. So obviously I'm just going to write a 0 and go to the left. Here, I'm going to be met with a 9 and I'm just going to write a 0. And I'm going to go to the left and I'm going to break the loop. Well, that's great. That is partly the right answer that I need. But if that is the case, so if every single number was 9, I'm not going to return anything from my loop. And at the end, what I'm going to do is I'm going to take this array. So I'm just going to take this array, create a new array with one more element inside. So if this is 4 elements, what I want is to create an array with 5 elements. So I'm just going to create new 5 elements. All right. And of course, I'm just going to have the 4 zeros from the first one. And you guessed it, we're just going to be placing a 1 here. And we're going to have the correct answer. So that's going to be the check that we need to perform. All right. Well, that's pretty great. I'm now going to Control Z to return the JavaScript code. And for some reason, it doesn't want to return back. All right, there we go. And let's see how we're going to do it in JS. So the first thing that I'm going to do is to say for. And I said that I want to go from the end to the front. So I'm just going to say let index is going to be equal to the digits dot length minus 1. That's great. Now I want to perform this action until my index is 0. Or at least not until it's 0. It's if it's until 0, it's going to be like that. Until it's bigger or equal than 0. And I'm just going to drop it down. All right, so this is going to give me this loop from the back to the front that I was talking about. Now, here comes the interesting part. I'm just going to check if the digits of the particular index is less than 9. Now, that's the simple case, as I said, and let's draw it again just to be completely sure. I'm going to have 1, 2, 3 as elements, and I will be starting from the end. Now, if this is less than 9, it means that I don't have any carry, right? It means that I don't have 1 as a carry, so it's just going to be completely valid if I increment this by 1 and then just completely return the array. So that's going to be okay. Now, if that is the case, I'm just going to say digits of the particular index is going to be plus plus. And of course, I'm just going to be returning the array since I don't need to perform anything else. So that's nice. And again, if we had, let's say 4 9s, I am just going to take this and make it a 0. So this is easy. Digits of the index is going to be equal to 0. All right. So that is pretty nice. Digits of index is equal to 0. And now we need to take care, because this is going to take care if I have 9, 9, 9, and 1. It's just going to return 2, 0, 0, 0. And actually, it's going to be like that, 2, 0, 0, 0. So that's good. But if I have a 9 as well, I'm going to return 4 zeros, and I don't really want that. So again, the thing that I have been talking about, I want to make sure that I'm going to create a new array with not these much elements, but with one more, because I'm going to need the 1, and then just append the 1. In order for us to do that in JS, I'm just going to say let result array be equal to an array of digits length plus 1, and then I'm just going to fill the array with zeros. Now, this is pretty much straightforward, I think. If I have 4 zeros in here, I'm just going to create a result array, which is going to be having the digits length plus 1. So digits was 4 9s. And now I'm just going to have 5 elements here. So I'm just going to create an array with 5 elements, and I'm going to be filling them with zeros. So in reality, result array is going to be holding 5 zeros. It's going to be like that. And all I really want to do is to get this 0, take it away, and add a 1 here, because this is going to be the carry. Keep in mind, the carry can only be 1. It cannot be 2 here. So currently, what I'm going to do is I'm just going to say result of the first index is going to be equal to 1, and of course, return the result. And that should be it. Let's actually check the code and see if it's going to be running properly. All right, and then just send it to the server. And we have a problem, so let's actually see what we are missing. Result of 0, and of course this is not result, this is actually result array. Result is something not found, and I have a runtime error. I hate that, but it happens. And again for some reason I'm saying result. Okay, this should be it now. So let's submit a third time, and hopefully it works. There we go. So the final thing that we need to be talking about, I suppose, is the time complexity. And the time complexity may seem pretty straightforward, being linear, but you need to keep in mind that we're actually creating a whole new array here. So actually the time complexity is going to be big O of n. And that's not true as well. It's actually 2 times n. But since we're not taking at the constants, I'm just going to remove this, and it's going to be linear. The space, however, is going to be not constant. It's also going to be linear, because if I have, let's say, 10 bytes here, or 10 megabytes, it doesn't really, or 10 gigas, right? Gigs. I'm just going to create basically the same array, if, of course, the program space allows me to. So the space complexity is also linear. And that's pretty much it. Thank you for watching. Subscribe, and I'll see you in the next one. Bye.